Okay, here we go with video number 3 from this segment length topic. And so this one should be the shortest. These are the easier examples that we need to do out of this one. But we've got in this triangle ABC that we see in this picture, the circle D is inscribed. That means that the circle is just big enough where all 3 sides of the circles intersects the triangle at exactly one point. It says that you have a tangent. It's tangent to the segment BA at point I, and tangent to BC at point H, and lastly tangent to the side AC at point J. So here is one fact that you need to know in order to understand what I'm about to do in this question. So the fact is, 2 tangents from the same external point are congruent. And what I mean by that is, when you look at this picture, you have an external point of the circle, that is point B. B is on the outside of this circle, and the tangent from B to I has to be the same or congruent to the tangent from B to H. So this segment and this segment have to be congruent to each other. How about the point A is external to the circle, and AI and AJ are both tangents. So AI must be congruent to AJ. And lastly, CH must be congruent to CJ. Okay, now that all being said, when you go here and it says the length from A to I is 6, that means the length from A to J must be 6. If the length from B to H is 4, then the length from B to I must be 4. If the length JC is 13, then the length from H to C must also be 13. And now it'll be very easy to determine the perimeter of the triangle. I just have to add all of these numbers together to find what the perimeter must be. So the perimeter of the triangle would be when we add up all of these parts together. That means the perimeter is 36. Okay, so that's 2 tangents from the same point always have to be congruent. Now, the last example, example 5 down here says, in this example or in this diagram of circle A. So we see this is the one time where it's really important to recognize that when they say this is circle A, that A is the center of the circle. Okay, and so you have a tangent drawn from point C to B. You have a radius. It tells you right here, even though it says it's a circle A, it's just letting you know that from A to B is a radius because you have a point on the circle, a point in the center of the circle, and you have a secant CDA. Now, because if that were to continue, it would intersect the circle twice. Now, we know the length from A to B is 3.3. And you know the length from C to D is 5.6. And what we want to figure out is what's the length of C to B. Okay, well, there's a couple things that have to be true in order to see this. Let's take note of these things right here. So here's 2 facts. One of them I know you know. It's just kind of hard to tell what you're looking at in this picture. That BA was a radius. You were told that. But DA is a radius as well, and that in a circle, all radii are congruent to each other. So this length must also be 3.3. Now, the other thing is it looks this way, but here's how you can prove it. When you have a tangent like CB and you have a radius like BA, where they both meet at the point B, those make a right angle with each other. So since that's a right angle, because the tangent and the radius always make a right angle, then this triangle now turns into a right triangle. And we just finished all of Unit 5 that says that if you have a right triangle, we are allowed to use a certain set of equations that will help us figure out what lengths are. And if I know the length of the side from B to A is 3.3, and I know the length of this entire side from C to A would be 8.9, and I want to find the length of the third side, then the equation that would best suit this this problem will be the Pythagorean theorem. A squared plus B squared equals C squared. Because I don't have any measures of angles outside of the 90 degrees, but I do have the lengths of 2 sides and want the third. I have the length of the hypotenuse of this right triangle and one of the legs. I just need the other leg. So let's go ahead and substitute. I'm going to say x squared plus 3.3 squared is equal to 8.9 squared, and then we go ahead and solve that equation. So x would be about this length right here, but since again all of my numbers are to the nearest tenth, I decided to keep the length CB to the nearest tenth. I said 8.3 would be the length of that segment. So that wraps up all the different types of questions you're going to see for lengths of segments that are in and around circles. I hope this helps to complete our practice problems and ultimately you to be successful on your test. Bye-bye.